morning friend. Today we are starting the problems again on the chapter 9. First one, an object of the size 3 centimeter is placed 14 centimeter in front of a concave lens of the focal length 21 centimeter. Describe the image produced by the lens. Describe the image produced by the lens. Now in this condition, first we have to write the given term. In this, they have given that the size of the focal length. Size of focal length is equal to 3 centimeter. And in the same way, they have given the size of the object. Size of object is equal to 14 centimeter. And in the question, they have kept in front of the concave length of the focal length 21 centimeter. They have mentioned the focal length, that is F. F is equal to 21 centimeter. Focal length, we are considering F is equal to 21 centimeter. Now, by using this, here we have to find the image. What is the image produced by the lens? Now, these are the given term. In this, again, we are considering that the image distance is equal to B. Image distance is equal to B. Now, according to the lens formula, 1 by V minus 1 by U is equal to 1 by M. Now put the values of V, U, F. V is equal to V is there. Just put the value of U. 1 minus U is, we are considering U value should be 21. Next the formula 1 by V is equal to, we are considering 1 by F plus 1 by U. Put the value of F and U. 1 by V is equal to 1 by F 21 plus 1 by U 3. Now here we have to calculate the value of the 1 by V. Therefore we are getting the answer V is equal to 8.4 centimeter. The value of the V is equal to 8.4 centimeter. Here we can also tell that the image is formed on the other side of the lens is 8.4 centimeter away from it. Therefore, it is erect and virtual. Here we can tell that the V is either erect or virtual. The value of V is erect or virtual. In the same way, we have to also calculate here the magnification of the image. Therefore, the magnification of the image is given by formula we are writing M is equal to H2 by H1. And here we have to know the value of H2 and H1. Or this can be also equal to, we are taking it as V by U. Now put the value of V 8.4 divided by U. We are considering it as U is equal to answer. We are taking 14. Therefore, calculate. We are getting the answer as 1.8 centimeter. 1.8 centimeter. Now see here in the question we have to describe that the image produced by the lens. Total answer we are getting has the 1.8 centimeter. Now second question. The light from a source in the air falls on a spherical glass surface. where refractive index is equal to 1.5 and radius of the curvature r is equal to 20 centimeter. The distance of the light source from the glass surface is 100 centimeter. At what position the image is formed? Here also again we have to find where the image is formed or at which the position is formed. Now in this first we have to write the given term. First we are considering the radius of the curvature r is equal to 20 centimeter. Next they have given a refractive index is equal to 1.5. Now let us consider n1 is equal to 1 and n2 is equal to 1.5. And they are told that the distance of the light source from the glass surface is 100 centimeter. Therefore u is equal to minus 100 centimeter. We are considering u is equal to minus 100 centimeter. In the same way here we have to find the v is equal to question mark. V is equal to question mark. Now let us consider the formula. The formula we are considering n1 by u minus n2 by v. n1 by u minus n2 by v is equal to n1 minus n2 by r, radius of the curvature. Now put the values of n1, n2, r and calculate the value of v. Or this can be also written in the form of n1 by u, just put the values. Now 1 by u 100 minus n2 by v is equal to n1 means 1 minus 1.5 divided by r, radius of the curvature is 20. Or this can be written as minus n2 by v is equal to 1 minus 1.5 divided by 20. Take this side minus 1 by 100. Or minus n2 by v. Now just we are calculating the calculation part is there. We are getting the answer as minus 0.025. Total the calculation part we are getting the answer as minus 0.25. Therefore here we are getting v is equal to plus 100 centimeter. V is equal to plus 100 centimeter. Now when we are calculating this part, how much we are getting? Minus n2 by v is equal to minus 0.025 or v is equal to 100 centimeter. In this case we know the value of n2. n2 is equal to how much is there? 1.5. 1.5 by v is equal to minus 0.025. Okay. Now calculate the minus sign. Next we are getting v is equal to 100 centimeter. Now in the question what we have to find? Here the position. At what position the image is formed? Here we can tell that it is at the 100 centimeter. The image is formed at the 100 centimeter. Next, third question. A convex lens has the focal length of 0.1 meter in A. Calculate its power. P is equal to question mark. We have to find the power. If the lens is completely immersed in the water, what will be the change in the power of the lens? Here we have to calculate or we have to find the value of what is the change in the power of the lens. Now first write the given term. The given term Ng is equal to 3 by 2, Nw is equal to 4 by 3, F is equal to 0.1 meter. Now in this condition we have to calculate the power of a lens. P is equal to formula 1 by F. F is the focal length. Put the value of F 1 by 0.1 is equal to 10. B. The focal length how much we are getting, or sorry, the power of a lens P is equal to 10. Now next in the same way again here we have to find the focal length of the lens in the A. Focal length of the lens in the A. Okay. The formula we are calculating has 1 by f is equal to Ng minus 1. 1 by f is equal to Ng minus 1 into 1 by R1 minus 1 by R2. Now in this condition we know that one f value we know the value of Ng. Just here we have to calculate the value of 1 by R1 minus 1 by R2. In the same way again here we have to write the focal length of the lens in the water. The formula for the focal length of the lens in water. Therefore 1 by f is equal to NW minus 1 into 1 by R1 minus 1 by R2. First one we have taken in the air, second one we are considering the focal length in the water. Now dividing equation 1 by 2. Now let us consider this as equation 1 and 2. Now dividing equation 1 by 2. We are getting the equation as 1 by f is equal to Ng minus 1 into 1 by R1 minus 1 by R2 divided by 1 by f is equal to NW minus 1 into 1 by R1 minus 1 by R2. Now here some term get cancelled. Cancel the term. Total answer we are getting here FW by F is equal to we are considering Ng minus 1 divided by NW minus 1. Now here we are considering the formula FW by F is equal to Ng minus 1 divided by Ng or divided by NW minus 1. Put the values of Ng and NW, we can find the value of FW by F. And here we know the formula for the F is equal to 0.1. Therefore the value of FW is equal to 0.5 divided by 0.1252. Next we have to calculate the value of FW. Take this 0.1 here. 0.5 into 0.1 divided by 0.1252. Now the value of FW. The value of the FW is equal to 0.4 meter. FW is equal to answer we are getting how much 0.4 meter. In the same way here we have to find the power of the lens in the water. Therefore the power of the lens in the water PW is equal to we are considering 1 by F into W. Therefore 1 divided by 0.4. The value of 1 divided by 0.4 is equal to 2.5 D. 2.5 D. And in the question see there what we have to find, what will be the change in the power of the lens. Here we have to find the change in the power of the lens. Therefore the formula P dash is equal to P minus PW we are considering. Change in the power of a lens. P dash is equal to P minus PW. Now put the value of P and PW. The value of P is 10 minus 2.5. 2.5. Therefore the total value is 7.5. Therefore in the question just we have to find the change in the power of the lens. Here the answer we are getting how much change in the power of the lens. P dash is equal to 7.5 D. This is the answer. Now the last question. The power of a concave lens is 2.5D in air. Find the change in the power when it is completely immersed in the water. Of refractive index 4/3 and refractive index of the material of the lens is equal to 3/2.